Section 3.7 is on related rates. So what is this about? This is application problems. Really what we're doing is implicit differentiation here. What we're going to be looking at is real-world problems, and now we're going to be looking at the variables with respect to time almost on all problems. So when we find the derivative of x, it used to be just 1. Well, just like the derivative of u is u prime, the derivative of y was y prime, now the derivative of x is going to be x prime, where it's really dx dt, because every one of our variables now is going to be a function of time for the vast majority of these problems. So now anything you take the derivative of, just remember essentially the derivative of x is no longer 1, it is x prime. Everything else is just the same as we've been doing in the implicit differentiation section and the previous section with inverse trigonometric functions. So let's take a look at this. It says finding related rates. In the previous section, we looked at implicit functions. We said that y is a function of x. Thus, we concluded that the derivative of y, which we used y prime, or dy dx. In this section, we will think that every variable is an implicit function. For instance, we can think of both x and y are functions of time, t. So we would have the derivative of y and x are y prime and x prime, or dy dt and dx dt. Again, I use the prime notation when I teach. The book uses the derivative with respect to t, so the dx dt and the dy dt. Exact same thing. It says we want to make sure to use the chain rule when appropriate. It says, for instance, suppose you have x and y are related by the equation y equals 2x. If both variables are changing with respect to time, then the rates of change will also be related. So in other words, we can take the derivative of both sides of the equation with respect to t. And if you take the derivative of both sides of the equation with respect to t, on the left-hand side, let me go ahead and do that. So the derivative with respect to t on both sides, because the variables don't match, on the left-hand side you would have y prime, and on the right-hand side the derivative of 2x would be 2x prime. And that's all they're saying right here. You have your y prime and your 2x prime, except they use it as dy dt and 2 dx dt. It says this techniques can be used for many application problems called related rates. For example, when water is drained out of a conical tank, the volume v, the radius r, and the height h of the water level are all functions of time t. Knowing that these variables are related by the equation, well, it's a cone, right? So what's the formula for a cone? The formula for a cone is volume is pi over 3 r squared h for volume. So what do? Take the derivative of both sides with respect to t, and remember every single variable is implicit. So what would the derivative of v be? The derivative of v would be v prime, or dv dt. And then what would you have to do on the right-hand side? Well, you would have to consider that the product rule, with the first function being pi over 3 r squared and the second function being h. So you do the first, which would be pi over 3 times r squared, times the derivative of the second, well, the derivative of h would be h prime, plus the second, which would be h, times the derivative of the first, which would be 2 pi over 3 times r to the first power, and then you need the r prime, right? All they did was factored out the pi over 3, but everything else they have is the same as what I just said. So when you do that, you have a related rate, rates of change. We have that the v prime would be equal to, again, they just factored out the pi over 3 times r squared times h prime plus 2rh times r prime. It says, from this equation, you can see that the rate of change of volume is related to the rates of change of both h and r. So here's the rate of change of volume on the left, the rate of change of h, and the rate of change of r. So what's the idea here? We're going to be given word problems where we know a lot of the information and we don't know one of them. So for instance, in this equation, we have a v prime, an r, an h prime, an h, and an r prime. So v prime, r, r prime, h, and h prime. That's 5 separate variables that we would need to plug in for. Well, we would know 4 of those variables. 4 of those variables would be given to you in the problem. So you plug in the 4 things that you know, solve for the one thing that you don't know. So that's what these problems are going to be. They're going to be looking at formulas like the volume of a cone that you've seen before, volume of a sphere, area of a circle, volume of a rectangular solid or a cube. Formulas you know, we're going to take the derivative with respect to t and then plug in our unknown information or given information, solving for the unknown information.